Alright guys, this week we are going to be talking about altitude, air pressure, temperature, density, greenhouse effect, and climate change. So lots to get through. I'll make this as quick and painless as possible. Okay, so starting with altitude. Altitude is the height of anything in reference to the sea level on Earth. So anything that sits above sea level is altitude. A good example is as a plane takes off, its altitude is increasing. So as you go up in the troposphere, if you climb a mountain, your altitude is increasing. Next is air pressure. Air pressure is the force exerted by air, whether compressed or unconfined, on any surface in contact with it. Basically, that means it's just the air pressing down on something. Here's a good example. When you blow up a balloon, you're increasing the amount of air pressure inside the balloon, which causes it to expand. Next we have temperature. You guys probably know what temperature is. It's the measure of the warmth or coldness of an object or substance. Okay? That's pretty self-explanatory. You guys have been dealing with temperature for a long time. And then we have density. Density is mass divided by volume. It's the measure of how much mass there is per volume. So if you look at the example down here, you can see that the warm air molecules, it's less dense. There's less of them because warm air, it spreads out. The molecules are more active. They need more room. Cold air molecules are more dense. There's a lot more of them in the same area. Okay, those cylinders are the exact same size, but warm air, there's not as many molecules as there is for cold air. Just like penguins in the winter, they want to huddle together when they're cold. And when you're hot in the summertime, you don't want your friends hanging all over you. So you need more room when you're hot and less room when you're cold. Okay? This is objective 9. Those are the 4 words that I just explained to you. I can define altitude, air pressure, temperature, and density. Make sure you're writing down the objective and then everything on this slide underneath it. Okay? So go ahead and write down objective 9, altitude, air pressure, temperature, and density, and define all of those. Go ahead and pause and write that down now. Moving on, objective 10, I can describe how altitude affects air pressure and temperature. When we're talking about air pressure, we're talking about as we go up in the atmosphere, what's happening to our air pressure. Well, as we go up, there's less air pressing down on us. So as altitude increases, sorry, I went too far there. As altitude increases, air pressure is going to decrease. Think about of all those layers. As you're going up from the troposphere, which is the bottom layer where all our weather is, where we live, as we go up in there, there's less pushing down on us. When we're all the way down at the bottom, all the air pressure from the troposphere, the stratosphere, the mesosphere, the thermosphere, it's all pushing down on us. So as we go up, the air pressure goes down. Go ahead and pause here. You're writing down objective 10 and how altitude and air pressure are related. Go ahead and pause and write that down. Okay, moving on. This is the second part of objective 10. So in a minute, after I'm done talking, you're going to write this down too. How are altitude and temperature related? This is related to the lab that we did in class last week. Or I guess if you're watching this, you're going to do it this week in class. You'll see that as altitude increases in the troposphere, your temperatures are going to go down. Think about the tops of mountains. They're usually white because there's snow up there. The temperatures go down when it's cold in the troposphere. However, when we get into the stratosphere, our temperatures are going to go back up. In the mesosphere, our temperatures are going down again. And then when we get into the thermosphere, as we rise up through the thermosphere, our temperatures are going to get hot again. Okay, so remember that W shape. That's going to be really beneficial to you. As you're taking quizzes on this, as you're remembering what happens to temperature in each layer, if you just remember that W shape, we go down in the troposphere, up stratosphere, down mesosphere, up thermosphere. So go ahead and pause this. You are writing down the rest of objective 10, this whole slide, and the W shape, and label what happens to temperature in each of those layers with the W shape. Okay, we are going to move in and talk about ozone. What you need to remember is ozone is good up high and it's bad nearby, and I'll explain that to you in just one second. Here's our objective 11. I can define ozone and identify good and bad ozone. So ozone is O3, which means there are 3 molecules of oxygen that bind together and that creates ozone. Oxygen is O2, two atoms of oxygen bind together to form oxygen. Ozone is O3, so it's just 1 extra oxygen atom that binds. Okay, so ozone is a gas that occurs in Earth's upper atmosphere and at ground level. So the good ozone is the ozone layer, the one you've heard about. It's a thin layer in the stratosphere, and it protects us from the sun. Okay, it's located about 10 to 30 miles up from the surface, and it blocks UV rays from reaching us, and it makes up about 90% of ozone. So 90% of all the ozone in our atmosphere is in the ozone layer. But we have this other 10%, which is our bad ozone. It's found close to the surface of the Earth in the troposphere, and remember that's where we live, where all the weather takes place. It makes up that other 10% of the ozone in our atmosphere, and the main ingredient is urban smog, which is fog plus smoke. It's harmful to us, it's harmful to breathe, it damages crops, trees, and other vegetation, and it's considered a pollutant. Okay? Go ahead and pause and get down objective 11. Write the objective out. I can define ozone and identify good and bad ozone, and then everything on this slide underneath it. Okay, so moving on. Well, what does that mean for us? If we have damaged our ozone layer, and I know you guys have heard that there's like a hole in the ozone layer. That's true. There is a hole in the ozone layer, but as you can see here, this is our normal ozone. You can see that all the UV rays that are coming in from the sun, that most of them are getting blocked and only some of them are getting through. But when we have damaged our ozone layer, look at this one. This is a damaged ozone layer. See all these UV rays that are getting through and only some of them are getting blocked? That's a problem for us, and it can create a lot of problems. All right, let's first talk about what causes that ozone depletion. Chlorofluorocarbons, CFCs, they used to be found in a lot of refrigerants, and they've been like aerosol hairsprays in the past, and hydrochlorofluorocarbons also, and coolants. And a lot of these things we no longer use. We didn't know that they were harming our environment when they were created before. Other ozone depletion is caused by foaming agents, fire extinguishers, solvents, pesticides, and again aerosol propellants that I talked to you about, which a lot of these we don't use them anymore. But those are the things that are causing our ozone depletion, and that's why our ozone layers is thinning out. So if we have those things depleting our ozone layer and more rays are getting through, like I showed you in this last slide, what's going to happen to us? We're going to have more causes of skin cancer. We're going to have an increase in melanoma, which is, again, skin cancer. It's going to impair our immune system. Down here is an example of cataracts, which is an eye disease, and it has it just affects your eye. We can, more UV rays can damage crops. We can reduce our crop yield, which is how much we get from a specific crop. And it's going to decrease phytoplankton, which is the base of the food chain in the ocean. So if we take out the base of the food chain in the ocean, that's taken out a lot of other animals, and that's going to affect then our food supply. So we have to really think about what we're doing and how we can stop using these things that are harmful to the ozone. All right, moving on. This is what I was talking to you about with, is there, that you've heard that there's a hole in the ozone layer, and this is the evidence right here. You can see this earth and you see this purple area right here. That's where the hole is forming. There's not a lot of protection there. So we have to do all we can to reduce the amount of ozone to reduce the amount of chemicals and things that we're putting into the atmosphere that's damaging our ozone layer. So what are we doing to help our ozone layer? How are we going to get it back to where it was? Because it can heal itself. It's not that there's a hole there and it's going to be there forever and ever. It can heal itself. So the Montreal Protocol of 1987 phased out the production and use of ozone-depleting substances. The EPA has established regulations warning labels, which must be placed on all products containing CFCs, which is the chlorofluorocarbons, like hairspray. Releases into the air of refrigerants used in cars and home air conditioning units and appliances are prohibited. Remember, I told you that we have changed all of those things. We're using different things now. We used to use those refrigerants that contain CFCs, and we no longer do. We have produced substitutes to ozone-depleting products, and if we can continue to stop using things that deplete our ozone, then by about 2050, our natural ozone production should return, and the ozone layer can repair itself. Objective 12, I can describe the greenhouse effect. A lot of people think that the greenhouse effect is a really bad thing, when in reality, the greenhouse effect is the reason why we are able to live here on Earth. The greenhouse effect traps those UV rays on Earth, and it forms a blanket around the Earth, which keeps those greenhouse gases inside the Earth, and they absorb the heat, which makes it nice and warm. So the greenhouse effect traps heat near the Earth's surface by greenhouse gases. So those are carbon dioxide and methane, and that's important for you to know that greenhouse gases are carbon dioxide and methane. And they form a blanket around the Earth to keep it warm here. Without the greenhouse effect, Earth would be much colder, about 33 degrees Celsius colder on average, and everything on all the Earth's water would be frozen. So the greenhouse effect is a good thing. It's not a bad thing. It's a good thing. Go ahead and pause this. Write down Objective 12. I can describe the greenhouse effect and the 2 bullet points underneath it. Objective 13, I can describe climate change. Climate change is under the category air quality because that's what we're changing here. The properties of climate change are that the causes of it are both natural and man-made. It used to be called global warming, but it's not called global warming anymore. It's called climate change. And too many greenhouse gases are the problem. Remember, we just talked about methane and carbon dioxide being greenhouse gases. And so climate change is caused by too many greenhouse gases. What are some warnings of climate change happening? Stronger storms, more intense summers and winters, and Earth's average temperature continues to rise. Okay, that is climate change. Go ahead and write down Objective 13. I can describe climate change and draw this concept map underneath it. This is continuing climate change, so this is going right underneath the concept map that you just drew. Climate change is an average increase in the temperature of the atmosphere near the Earth's surface and in the troposphere, that's where we live, which can contribute to changes in global climate patterns. And it can occur from a variety of causes, both natural and human included. And why does it affect us? Because glaciers, permafrost, and sea ice are disappearing. Sea levels are rising, seasons changing, and extreme weather is becoming more extreme. And it could lead to more droughts, floods, and intense storms. Go ahead and pause this rest of Objective 13 and get this written down. All right, what can you do to help? You can become what is called an environmental steward. It's someone who protects the environment through recycling, conservation, regeneration, and restoration. Taking responsibility for our choices. We have to live here, our kids have to live here, our grandkids are going to have to live here, so we need to protect the earth and be environmental stewards so that the earth is still in a good state for them. The responsibility for environmental quality should be shared by all those whose actions affect the environment, which is every single one of you. Every single one of you is going to leave a carbon footprint, and you want the smallest carbon footprint as possible. We'll talk more about that in class. Okay, that is it for this week. I'm going to go to a Brain Pop video if you want to continue to watch this. It's real short. It's only about 3 minutes.
Hey, it sure is warm for January. Dear Tim and Moby, what does global warming mean? From Walter. Well, global warming means that the Earth is heating up. In the last 100 years, the surface temperature of our planet has risen about 3/4 of a degree Celsius, or a little more than 1 degree Fahrenheit. Most scientists believe it's going to get even warmer in the years to come. What's making temperatures rise? Well, there are probably many factors involved, but most scientists agree that the biggest contributor to global warming is the increase in greenhouse gases like carbon dioxide in our atmosphere. These gases trap in heat and cause a natural heating up called the greenhouse effect. Inside my mom's greenhouse, the sun's radiation comes in through the glass and heats up the air inside. But that air doesn't go anywhere, so it becomes warm and humid, which is good news for the plants. On Earth, a similar thing happens. The sun's radiation travels through our atmosphere, heating up the Earth's surface. Excess greenhouse gases in our atmosphere trap that heat in. So the Earth eventually becomes hotter, just like the inside of my mom's greenhouse. So what's the big deal if it gets a little warmer? Yeah, well, warm winters can be nice, but increased temperatures can cause problems for the environment. Coral reefs die due to warmer water temperatures, and fish have to go elsewhere for food. Earth's polar ice caps hold a lot of water. A difference of a few degrees in temperature can melt this ice, causing the sea levels to rise, which could flood coastlines, affecting the habitats of plants and animals and people. Who knows what will happen to all the animals and people who have to adapt to new temperatures and wetter environments. Well, there are things that we can do to stop the accumulation of greenhouse gases in the air. Burning fossil fuels generates carbon dioxide, so the more you walk or bike instead of driving, the clearing fewer forests is a good way to start. Boy, this weather sure is freaky. I didn't mean you should plant trees in the yard. Well, I guess his heart's in the right place.
Okay, so I will see you guys in class. Make sure you got all your notes down.